I have been asked many times to make a simple presentation about cancer, about where it comes from, what it is, and how it can be cured even. But in particular, I've been asked about, and I've also made presentations about, the cancer epidemic, which started in about 1980 and has increased and continues to increase and is now affecting young people. So this is the first part of two videos I want to make about this issue. The second one is more about what we can do about the problem. But let me first try to present the problem very simply. Cancer is a genetic disease expressed at the cellular level. That's not my words. That's a quotation from Sir Walter Bodmer, who was at one time the head of the Cancer Research Society professor who identified cancer as a genetic disease. And cancer is a genetic disease. What do I mean? What do we mean by a genetic disease? Well, living systems operate with messages that are written down in the genetic structure in the cells of the individual, and these are passed on to their children, and their children pass on to their children, and so on. A specific set of if you like, coding instructions, like a library, so that when the body wants to know how to do something, or some single cell in the body, let's say a liver cell, wants to replicate and make another liver cell, or in the embryo, right at the beginning when the little baby starts, the genetic information that it receives from its mother and its father tell it how to grow. So therefore, you know, people end up looking a bit like their parents or their grandparents, because the instructions are the same instructions. And these instructions, as most people know now, are coded onto a molecule, a very large molecule, that lives in the center of the cell. And this molecule is called DNA. It's a long, twisty spiral thing, and I've made a little model of it here. You can see this. See it. What you see here are a set of instructions coded onto this spiral DNA molecule, and the way it works is that the reason for it, the reason why there is such a thing, is that there is in the environment, there are various things in the environment that can attack the instructions. The instructions are therefore coded. The instructions are coded onto two opposite strands, and they consist of various molecules which are called bases. Well, we don't need to be interested at this stage what they are. You can think of them as an alphabet, and the way in which it works is that the alphabet on one strand is always opposite a particular alphabet code on the other strand. So if you see here, you can look at this, you can see that red is always opposite grey, and red is opposite grey, but we've now got blue, which is opposite orange. See that? And then here we've got blue on this side, which is opposite orange, and we're back to grey and red, and so on. And it's an enormously long thing. This is just a little section of it. Okay? So this is what's meant by a genetic disease. A genetic disease is a disease, or it's a condition where this molecule is destroyed. So in other words, something comes along and attacks it and pulls off one of these colours. I'm going to pull off the orange one here. So if this happens, then there are repair mechanisms in the cell which have developed over evolutionary timescales, in which the cell knows that because there's a blue here, there has to be an orange there. So some enzymes come along and they pop the orange back on. See that? And it's a repair. But if both of them are busted, because the actual molecule is attacked in such a way that both sides are broken, then the cell doesn't know how to repair it, and it repairs it wrongly. And sometimes what happens is that the energy from something that breaks it breaks the entire DNA. So you have 2 bits now. See that? And what can happen is that they can go back the opposite direction. Instead of going back the right way, when they repair, they come back and they go back opposite, in the opposite direction. And so what happens then is that the library code of the genetic material is changed. So maybe the code said, go down the road and buy some ice cream. It's just a possible explanation of how this works. But then when you break the code, it says, go up the road and buy some coal. And of course that's meaningless to the cell, or it might not be meaningless to the cell. It might actually mean something different. It might tell the cell to do something different. And when it does that, what you have is a mutation. A mutation means that the library has been broken. Some new information has been brought into the library. Some new information has come into the library. And this information is false information, and it's telling the cell to do something different than it's meant to do. Now, if you get what happens when the cell is damaged by any means, and these things are called mutagens, they're in the environment, and sometimes it's just a mistake that happens anyway because of the fact that like cars rust, human beings get old. And they get old because of destruction of the material in the DNA. Over a long period of time, the DNA replicates, and then it replicates, and then it replicates. Because your cells don't last forever, you know. I mean, your cells, when they're damaged, they change. So the person that you are now is not the same person in terms of your cellular makeup as you were when you were younger. For instance, in 19, you had a set of cells. Most of these cells are not there anymore. They're the daughters or the daughters and the daughters and the daughters of those cells. And some of them are not the same because they've had these damaging mutations. Now, cells replicate in proportion to doubling, just like people. You double it. And all life forms, really, they double. So you have something and it turns into 2 things. And if both of those things contain the damage, then when they also turn into 2 things, you've now got 4 things which contain the damage. Do you understand? And then the next time they replicate, you've got 8 things. And then they've got 16 things, and so on. So you get an expansion of the damage. Now, one little piece of damage is probably not going to cause a big change in how the cell works. I mean, what it can do is kill the cell, or it can retain the damage. But as it continues to expand, it can receive new damage. So in other words, you can set up, at some point along the way, you get a second mutation. And so that then produces another load of cells which have 2 mutations now. And then you have 4 mutations and so on. Now, we know from experiments and from studying genetics that there are a specific set of mutations which cause the cell to forget what it is and to just start to replicate madly, out of control. So in other words, a cell that normally knows its business and it knows where it lives in the body and so on, suddenly decides that it's going to take over, and so it starts producing lots more cells like itself. And this grows and grows and grows and grows. And if it's not shut down at that point by something, then that becomes a malignant tumour, which we call a cancer. And of course, if it can't be checked, and there are various methods that are used to try and check these cells that are expanding. One of them is radiation therapy, and then another one is chemotherapy, where you put in a poison, a cell poison. And it selectively kills the cells that are replicating because those are more sensitive than the ones that are not replicating. But nevertheless, it also kills the ones that are not replicating, just as radiation does, you know. And so this radiation therapy with chemotherapy and all the other methods that there are for destroying cancer cells also destroy the body, and this results in horrifying side effects. But then where does all this start? That's what I want to talk about. How do we know where it starts and how it works? Well, we know that cancer is a genetic disease, because of lots and lots of experiments that show this, but also because of epidemiology. Epidemiology is the study of groups of people who are exposed to or live under certain circumstances and so on. It's one of the most important ways in which we can try and figure out whether we're living in a good society or not, or whether it's good to have done something or to have not done something, or whether we control, for example, the massive increase in pesticides that exist, the flooding of the environment with uranium and all sorts of things that we know to be mutagens, because in the laboratory we can actually test them out and show that they mutate cells. We can do that, and it's been done. And that's also how we know that cancer is a genetic disease. For example, there are epidemiological studies that follow populations. So you can look at the cancer rates in Japan, for example, where breast cancer is very, very low. The breast cancer rates in Japan are very, very low. But when the Japanese women emigrate and go to live in California, the breast cancer rate goes right up. So obviously it's something about the place that you live in that causes cancer. And all it can be about the place that you live in is what you eat and what you breathe, your environment. So cancer is an environmental disease as well as a genetic disease. And a study of twins, because you see with twins, of course, they have the same genetic makeup. So what you can do is you can look at twins, and lots of people have done these studies, and they can show that about 20% of cancers are genetically related. So in other words, in the epidemiological studies of twins, where you study lots and lots and lots and lots and lots of twins, and you look to see what cancers they have, you find that they have a 20% excess chance of getting some cancers. Mostly the chance is very much less than that, like 2% or 5% or something, but all of these studies have been done, and we know this. So the twin studies tell us that at maximum 20% of cancer is genetic and 80% is environmental. Right. So if it's environmental, what is it in the environment that's causing this damage? What is it that's breaking up these DNA strands and introducing these mutations? These mutations are like a sort of tombola, like a lottery. You know, in England we have a thing called housey or bingo, and so people go along to a big hall and they call out numbers. So the caller says number 11, and if you've got 11 on your card, you cross it off. And then they say number 27, and you don't have 27, so you can't cross it off, and so on. And eventually the person who gets all of the numbers on the card, they jump up and they say bingo. And they get all the money. They get a prize. So in the case of this, you have a similar sort of bingo in reverse, because when you get all the numbers, you get cancer. And that's how it works. And we know that from studying the rates of cancer with age. Because of this doubling issue, it's what we call exponential. So if you make a progression, a series where it goes 2, 4, 8, 16, 32, 64 and so on, that's an exponential increase. And so if you take the logarithm of an exponential mathematical series, you get a straight line. And you get this with age. So as you get older, you get cancer. And the older you get, the more cancer you get. But what we're getting now in the last 20 years is an increase in cancer in young people. So what that suggests, when you put in all the numbers, it suggests that those children have got the mutations already. So they're born with a bingo card in which half of the numbers are already crossed off, because that's their genetic makeup, you see. And the reason that numbers are crossed off is because their mothers or their fathers received genetic damage, so that mothers and fathers passed on material that was already broken. They did that. So these children then, they receive something like that. So half of their bingo card numbers are already crossed off. So we need to then now move to why the cancer is increasing. I have studied this for 30 years because I was very interested in it. I'm interested in life and how it works. And by studying how it doesn't work, you can get some idea of how it does work. So you look for the problems, and then that enables you to look back and see how it works when the problems are not there. Now, Albert Schweitzer, the missionary, he wrote in his diaries about his time in Africa. This is the 19th century, long ago, when Africa was hardly explored. And there are lots of similar stories about doctors who went to far-flung countries, to Togo and the South and the Pacific and the Australia, studying the Aboriginal people there. And cancer didn't exist. There was no cancer, none, no cancer. Schweitzer writes and says that in all his years in Africa, he never saw one case, not one. But I've been looking at Iraq. Some people in Iraq have asked me to look at Iraq in the last 20 years because they're afraid, they think, that all the tons of depleted uranium that were dropped by the Americans in the Gulf, in the two Gulf Wars, 1991 and 2003, that the uranium that was dropped and the uranium particles in particular that can be inhaled and cause genetic damage because they provide a very, very high dose close to the particle. You know, the particle gets very close to the DNA, and of course it produces lots of radiation. I mean, this for example, this is a Geiger counter, and it's going clickety clickety click. There it goes. You see, that's the background radiation in this room. And there's always some background radiation, and you can hear it going. But I have here an old army radium marching compass. See this thing, okay? And if I bring the radium close to this, you can see that the radiation increased. We can't see radiation. I mean, people walk about, it's invisible. You can walk about Fukushima, for example, which I have done in 2011, just after the accident, and there's lots of radiation there, but you can't see anything. The birds are singing, and the sun is shining, and the grass is growing, and if you didn't have a Geiger counter, you wouldn't know. And incidentally, this is about the level of radiation at Fukushima when I was there. And it's very high. And it will cause lots of cancer. But I'm getting ahead of myself. We know that mutagens cause cancer. We know that from the studies of the epidemiological studies of people who move across countries. We know it from the fact that there are substances which are banned by governments. You can't use these substances or buy them except under controlled conditions, that also cause mutations. They specifically attack the DNA. They're chemicals. For example, chimney sweeps in the 19th. This is one of the first epidemiological studies. Chimney sweep boys used to climb up chimneys. They would climb up chimneys to clean the chimneys in Victorian England and Edwardian England. I think I live here in Bedford, where there was a famous book written called The Water Babies by Charles Kingsley. There's a statue of Charles Kingsley down there. And in The Water Babies, the little boy who's the hero of the story dies. He's called Tom. He was a chimney sweep. We're not told how he died, or at least I can't remember. But a lot of chimney sweep boys died of scrotal cancer. That is to say that their testicles used to get covered with coal tar, because there's a lot of coal tar up the chimney. And coal tar is a carcinogen. It's a known carcinogen. They can paint it on your skin and you'll get a skin tumour. So these chemicals are carcinogens, and they've been around a long time, and as time goes on they've been controlled. So governments, the Environment Agency and so on, they say no, there's a limit to the amount of these materials that you can use, or they're actually totally banned and you can't use them. And there's a huge industry associated with looking at looking at all the chemicals that are ever produced. Every time they produce a new chemical for a pharmaceutical product or something like that, it's tested to see if it's a carcinogen. Now, in order to get to the DNA and cause damage, the chemical has to be eaten, or it has to be inhaled. So it has to be ingested or inhaled, and then it gets into the bloodstream. Once it's in the bloodstream, it floats around and it goes through the liver, and the liver has a huge load of metabolic enzymes that destroy carcinogens. So most carcinogens never get anywhere near the DNA because they go through all sorts of enzymatic detoxification reactions that kill them. And of course, we've evolved to do this. I mean, that's why we live so long. We live very long. We have long lifespans compared to most animals. And the reason for that is we have an excellent repair mechanism, one, and two, we have an excellent enzymatic system, chemical system in the body to destroy these carcinogenic compounds. But what we do not have is some way of dealing with radiation. Because radiation goes right through the body. It doesn't bother with the liver. It doesn't bother with the with being detoxified by any of the enzymes, because enzymes themselves get smashed up by the radiation. Radiation is like a bullet. Okay, it's like somebody shoots a bullet through this, like boom, and it goes through it, and it goes right through the body. So external radiation coming into my body, this stuff that's here now, it goes zap, 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 but all over the body, so generally. So it's been calculated, and it's easy to do these calculations. You can do them on the back of an envelope, that each cell in the body, and you have 10 to the 13 cells in your body, each cell in your body receives one track every year, and that's the background external radiation track, the dose. So that's that. Well, I say dose. I haven't defined dose. That's the stress from radiation in your body, and of course it can whack into the DNA and it can break it. Whereas a chemical carcinogen coming along won't do that, because mostly it's been intercepted on its way to the center of the cell. The cell has an outside bit, and it has a nucleus, and inside the nucleus are the chromosomes that then dictate what the cell is and what it does. Well, in passing, I should say one more thing about this, and that is that there is another there's another defense mechanism for radiation, and this is quite an important one, but hardly ever considered or assessed, and that is the ability of cells surrounding a prototumor. So in this case, what we've done is we've already got the genetic mutations in it starting to replicate, and it's getting bigger and bigger and bigger, and eventually, if it's not stopped, it'll sort of break into little bits, and then you'll get new tumours produced all over the place, in your brain, in your spine, here and there, and they all produce nasty chemicals, and then you die. Right, that's called metastasis. But there is a system whereby cells can control the prototumor when it's small. When it's small, the cells around it can shout at it and say, "Die." And this, we know that this happens. We know that it happens. If you look at autopsy specimens, I mean, I know this because I've talked to pathologists, and we dealt with this on the Depleted Uranium Oversight Board of the Ministry of Defence. When they were deciding to look at kidney tumours, they said, well, should we screen for kidney tumours? You can do that. You can do a screening test for kidney tumours. You can x-ray the kidney and look to see if there's any concentrations of tumours there. And this guy, Muir Gray, very famous guy, who was one of the members of the team members of the committee at that time, he said, we've done it. We've already did this, and we did a pilot study, and we found that loads of people have got kidney cancer all the time, but it goes away. And the reason it goes away is because the cells around the prototumor say die, and then it dies. And it could be that we can use this signaling system to shut down tumours, and this would be I can talk about this in another small presentation. But what I wanted to say at this point was that the biggest injection of radiation into the world environment occurred in 1959 to 63 with the nuclear weapons tests. So in other words, these things were tested in the atmosphere, bombs were tested in the atmosphere, and a huge amount of radioactivity was precipitated in the rain, came down all over the place, and people ate it. It got into their bodies. We can show this. We've measured it in their bodies. And by doing epidemiology and focusing on the people who were born around about that time, because this is when you're most sensitive. Obviously you're most sensitive because your DNA is replicating all the time when you're little, because you're growing. And so when you're growing, you have this massive 2, 4, 8, 16 process taking place all the time naturally, nothing to do with when it's damaged, it repairs itself and replicates, just as a part of the growth of the individual. And what happens is that, therefore, children born at that time, between 1959 and 63, will have received a large amount of internal radioactivity. And internal radioactivity is not like external radioactivity, because internal radioactivity comes from particular elements like strontium-90, barium-140, uranium-235, 238, plutonium, and all of these substances, all of these bind to the DNA. They have chemical affinity for the DNA. So when they get into the cell, they go clack, and they sit there, because they react with the phosphate backbone. This is what holds it all together, is phosphate. And normally, the phosphate is neutralized, or it's bound to calcium ions. But strontium is like calcium, it's the same group, and uranium as uranyl ion is also in the same group. And so these substances bind to the DNA. There they are, sitting right on top of it. So when they decay, they go bam, and they blow the thing apart. So internal radiation has a much higher danger than external radiation. But how do we know that? I mean, it's easy to sort of arm wave and say, look, it's closer to the DNA, therefore it must be worse. But a study I carried out a year ago, I specifically looked at the cancer rates in areas of high fallout, high radiation from the weapons testing, and compared it with low radiation areas. I looked at the western states of the United States, California, Arizona, New Mexico, and I looked at cancer rates, cancer death rates, mortality rates. And I compared them directly with the same group of people. So these are 10-year age groups, 5 to 10, 10 to 20, 20 to 30, 30 to 40. That enables you to identify the people who were born in 1959 to 63 and to see whether they had a higher cancer rate in the high fallout ratio in the southeast states, that's Tennessee, Kentucky, Alabama, where they had a lot of strontium-90, and it was measured. We have the data in the milk where they measured this stuff in the 1960s. So we know that there was a lot more radiation from strontium-90 and all the other stuff that binds to DNA in the southwest. And when compared to the southeast, when compared to the northwest, so in other words, you're looking at high radiation versus low radiation over time, you find that there's an enormous increase, a 52% increase in cancer in those people who were born in 1959 to 63. Well, what does that mean? It means that the cancer epidemic, which began in 1980, was caused by the nuclear test fallout. And it also means that the children of those people carry a whole cluster of genes that predispose them to developing cancer. And that is why the cancer rates are high in the world, in the West, where we can measure it, including in Iraq. So, what can we do about it? Well, there is actually something we can do about it, and that introduces a little booklet, 8-page booklet, which I will talk about in the next video that I make. This is the Veterans for Peace Uranium Weapons Working Group, and the information that is in there gives 13 scientifically proven and published examples of how we know that this radiation is thousands of times more dangerous than the current legal limits permit. and that as a result of this error, this scientific error, built into the structure of government limits on radiation exposure, because of that, 500 million people have died from cancer induced by radiation. So when people worry about COVID, and they worry about the First World War, and they worry about the flu epidemics, and they talk about the deaths in the concentration camps and the deaths in the Second World War, and all of these terrible, terrible disasters, these are nothing compared to the self-imposed erroneously developed system for controlling radiation exposure, and you have to stop it. And so this is, I started doing this in 2000, and I set up the European Committee on Radiation Risk. And then later on, I did it there was another one of these in 2010, and I've written 2 books on all of this stuff. But now we have to stop the development of nuclear, because nuclear is killing people all the time, including you. So I really don't want to get too exercised and shouty about all of this, you know. I'm just really trying to explain what's happened, so that people understand why it is that their family have developed cancer, and why their children might develop leukemia, and why their dogs develop cancer. You need to know this stuff, because you need to be able to do something about it. So I'm grateful. I think I may have rambled on a bit too long. But there's a lot to say. It's a complicated subject, and I hope that I've been able to explain it to you.